Today we are going to demonstrate the famous photoelectric effect. The effect was explained by Albert Einstein in 1905. The schematic diagram of the photoelectric effect experiment is shown in the figure. This is a zinc plate and this one is a copper plate. Copper plate is given positive potential with respect to the zinc plate by power supply. When electromagnetic wave with required wavelength is incident on the zinc plate, it emits photoelectrons. These photoelectrons are collected by the copper plate and will constitute a current. As the amount of the current is very small, so we have amplified it to microampere by a current amplifier using AD620 and observed the current by DC emitter. The current amplifier circuit is shown here. Let's start the demonstration.
This is zinc plate. Its work function is about 3.7 electron volt. So, electromagnetic radiation of wavelength 335 nanometer or less, that is UVC radiation, if incident on this zinc plate, photoelectrons will be emitted. Now this zinc plate having this stand is attached here perpendicularly. In this stand, a copper wire in the form of a spiral is attached. With this stand, this copper wire will act as anode to attract the electrons emitted from the zinc plate. This is high voltage DC power supply. This knob can be varied to increase the voltage from 0 to 10 kilovolt, that is 10,000 volt. This is the ground point, this wire, and this is the positive output. This is the positive output of the power supply. Now, this positive output is connected to the copper coil. This is ground point of the high voltage power supply. This is current amplifier. These 2 points are input of the current amplifier. The ground point of the current of the high voltage power supply is connected to the ground point of the current amplifier. This other point of the current amplifier is connected with this zinc plate. So basically this zinc plate is at ground potential and this copper coil is at positive potential supplied from this high voltage source. 10 kV is applied to this copper coil, that is the anode. The positive end of the 10 kilovolt power supply is applied to the copper and zinc is at ground potential. This is connected to the current amplifier. This is the ground of the current amplifier. This goes to the ground of the high voltage power supply. Now this is the plus 12 minus 12 power supply for this current amplifier, and we see that no current flows. Now this is UVC light. UVC light is taking closer to the zinc plate. UV light passes through this copper coil to the zinc line and emits electron. As a result, we see the photocurrent. The UVC light is coming closer to the zinc plate. That means intensity is increased, and we see that current increases. Now the UVC light is taken away. The current is decreasing, and it goes to zero. Now this is 60 watt ordinary bulb. I light it up and see there is no current. Now I am approaching the bulb towards the zinc plate, but there is no current. So this ordinary bulb emits no UVC, and there is no photoelectron, and hence there is no photocurrent. This is EV source, but it is soft UV, that is UVA and UVB. There is no UVC. Now you see that UV is incident on the zinc plate, but I am taking a closer, but there is no photocurrent. So this UVAB cannot emit any photocurrent. See, there is no current. Now I light up the EVC. EVC is taken closer to the zinc plate. The photocurrent increases. Closer, photocurrent increases. Closer, it increases much. Taking further away, and the photocurrent decreases, and it goes to zero as it is taken further. Now I am changing this polarity. That means zinc is given, that means the zinc is connected with the positive polarity of the power supply, and the copper coil is connected to this wire, which is connected to this. That means that now the zinc is at positive potential and copper coil is at negative potential, which goes to ground via this. Once again, this is positive zinc plate. This copper coil goes to the current amplifier and comes out from current amplifier to the ground point. Hence, zinc is at pulsating potential with respect to the copper coil. The current is 0. Now switch on the UV light. Now it is taken closer to the zinc plate. It is fully incident on the zinc plate, but there is no current.